Have you ever wondered why we move backward slightly when we release air from an inflated balloon? It's a phenomenon we've all experienced, yet few of us give a second thought to why it happens. Perhaps you've chalked it up to some mysterious force or a trick of the mind. But what if I told you it's not as mystical as it seems? It's an everyday example of a principle that governs the very fabric of our universe. A principle so fundamental, it's at the heart of everything from the push of a skateboard to the propulsion of a rocket. It's a rule that was first formulated centuries ago by one of the greatest minds humanity has ever known. So, are you ready to dive into the realms of physics? To uncover the truth behind this seemingly magical phenomenon? This isn't magic, it's the work of a fundamental principle in physics called Newton's third law of motion. Newton's third law states that for every action, there is an equal and opposite reaction. A simple sentence that carries within it a profound understanding of how the universe operates at its most fundamental level. But don't worry, we're here to crack open this nutshell and make sense of this profound law. So, let's break it down. Newton's third law is all about forces. Not just any forces, but pairs of forces. Picture two ice skaters. When one skater pushes the other, they both move. That's because forces always come in pairs. The skater who pushes applies a force, and the other skater experiences the equal and opposite force. It's essential to understand that these forces are equal in size and opposite in direction. Equal in size means if you push a wall with a force of 10 newtons, the wall is pushing back with the same strength, 10 newtons. Opposite in direction means that if you push the wall to your right, the wall is pushing you to your left. And guess what? This happens all the time, everywhere. Every step you take, every time you sit down, every time you lift something, Newton's third law is at play. It's like a silent symphony orchestrating our movements and interactions, whether we're aware of it or not. But it's not just about physical contact. Even when you're just standing on the ground, the earth pulls you down due to gravity, and you're pulling the earth up with an equal force. Yes, you heard it right, you're pulling the earth up. So Newton's third law is not just a statement about forces, it's a fundamental principle of how objects interact with each other. It's a principle that allows us to predict how objects will move and react under different circumstances. So when you jump off a boat, you push the boat in one direction, and in return, the boat pushes you in the opposite direction. And that, my friends, is the essence of Newton's third law. Newton's third law is not just a theory, it's a part of our everyday lives. It's so ingrained in our day-to-day existence that we often overlook it. Let's delve into some common examples to shed light on how this fundamental law of physics manifests itself in our everyday lives. Take, for example, the simple act of walking. When we walk, we push the ground backwards with our foot. In accordance with Newton's third law, the ground pushes back with an equal and opposite force, propelling us forward. So every stride you take is a testament to this law. Consider driving a car. When the car's tires push back against the road pushes forward, causing the car to move. This action-reaction pair is a perfect example of Newton's third law at work. The force exerted by the tires on the road is equal to and opposite of the force exerted by the road on the tires. Now let's talk about swimming. When you swim, you push the water backwards with your arms and legs. In reaction, the water pushes you forward, allowing you to swim. It's the equal and opposite reaction force from the water that enables you to glide through it. Even in the virtual world, Newton's third law is at play. In a video game, when your character jumps off a ledge, they are pushing down on the ground. The ground, in response, pushes them up and forward, propelling them into the jump. These examples are just the tip of the iceberg. The push and pull of everyday life, the constant interplay of forces, is a testament to the ubiquity of Newton's third law. It's not just an abstract concept studied in physics classrooms, but a living, breathing law that governs our daily lives. So the next time you walk, drive, swim, or even play a video game, remember this. Every time you push or pull something, you're experiencing Newton's third law in action. There are some common misconceptions about Newton's third law that we need to clear up. First and foremost, many believe that the forces in action-reaction pairs cancel each other out. This is a misunderstanding. Imagine you're pushing a wall with all your might. The wall pushes back with an equal force. But does it mean these forces cancel each other out? Not at all. You're not suddenly weightless or motionless. Instead, the wall's force is what's keeping you from going through it. Here's what's really happening. The forces are equal, but act on different objects. Your force acts on the wall, and the wall's force acts on you. They don't cancel each other out because they're not acting on the same object. It's like two people pushing a box from opposite sides with equal force. The box doesn't move, not because the forces cancel each other out, but because they're balanced. Another misconception is that the action and reaction forces always result in motion. Not true. Consider a book resting on a table. The weight of the book, the action force, pushes down on the table, and the table pushes back with an equal force, the reaction force. But the book isn't moving. Why? Because these forces are balanced, not because they cancel each other out. Finally, let's address the concept that the larger object exerts a larger force. This is a misinterpretation. Newton's third law states that for every action, there's an equal and opposite reaction. So, if a small car collides with a large truck, the force exerted by the car on the truck is equal to the force exerted by the truck on the car. The difference lies in the effect of that force. The smaller car will show a more noticeable change in motion because it has less mass to resist the force. Remember, the action and reaction forces act on different objects, so they don't cancel each other out. Let's remind ourselves that understanding the principles behind the laws of physics can help us better understand the world around us. Newton's third law is a fundamental principle that governs the physical world around us. It's an essential part of our understanding of how objects interact, and it's all around us, whether we realize it or not. To put it simply, Newton's third law states that for every action, there is an equal and opposite reaction. This means that any force exerted on a body will create a force of equal magnitude, but in the opposite direction, on the object that exerted the first force. Consider the simple act of walking. When we walk, we push the ground with our feet. This is the action. According to Newton's third law, the ground pushes back with an equal force. This reaction is what propels us forward. It's a clear demonstration of Newton's third law in our everyday life. However, it's important to note that these forces don't cancel each other out. They're acting on different objects. The force you exert on the ground isn't negated by the force the ground exerts on you. This is a common misconception about Newton's third law, and it's vital to remember that the forces act on different bodies. Also, the law applies to all types of forces, not just the obvious ones like gravity or friction. It's relevant when we're thinking about forces on a small scale, like the particles in a gas, and on a large scale, like the gravitational pull between the Earth and the Moon. In summary, Newton's third law is a fundamental concept in physics that describes how forces work. It tells us that forces always come in pairs and that they're equal in magnitude and opposite in direction. It's a law that's in action all around us, every day, in everything we do. So the next time you see a balloon flying across the room after being released, remember, it's all thanks to Sir Isaac Newton.